Hi. So in the last video, we discussed the property for the preference relation, which was the monotonicity, right? So and today we'll introduce another very important property, and which will be very useful as well. Okay, and that is called convexity. Okay. Okay. So convexity is also another very significant assumption or axiom, right? So normally we assume that the preference relation is convex. So we need to use the definition for the upper and lower contour sets for us to further define the convexity of the preference range. Okay, good. So let's make the definition for that. So this would be the definition in 3.b.4. Okay, so we say that the preference relation on set of alternatives or a consumption set X. So this is convex. Okay, so this is just a convex set, right? So you can simply think this as just a simple convex set in mathematics. Okay, so it is convex if for every element in X, the upper contour set that we defined in the previous video, upper contour set. So it will be the set including some elements which are at least as good as X. Okay, so it will be to the up and right of that indifference curve, right? So it means that is if we have 2 points, okay, let's say if we have y weakly preferred to x and another point z also weakly preferred to x, then the convex combination of those two y and z 2 points with some weights alpha and 1 minus alpha, this is all still weakly better or weakly preferred to x and for any alpha, which is just a real number between 0 and 1. Okay, so let's draw a little picture to help us further understand this definition. Okay, so we still have two-dimensional space for x. Okay, and let's say this curve will be the indifference curve and this point is little x. Let's suppose the y and z are some points here. Okay, so to the right and above of this curve, right? Because it's in the upper contour set. So let's simply connect those two dots, and this would be a straight line, right? Okay, so let's suppose this alpha is such that we have this convex combination and to some point, let's say here. Okay, so we have just some number alpha to make this point here. Okay, so this will be y and z, and this will be alpha y plus 1 minus alpha z, right? So those are all the vectors, right? So x is a vector, y is a vector, z is a vector, alpha y plus 1 minus alpha z, this is also a vector, right? Good. So, and this is still in the upper contour set. And then this property is just the convexity of this preference relation. Okay, good. So this convexity is very strong, but is a very important hypothesis in microeconomics, right? So the interpretation is that, okay, so before that, let's draw another counterexample where we have the preference which is not convex. Okay, and that'll be easy. Let's just reverse this indifference curve, and suppose this is x, this is y, and this is z. Okay, and we still have a straight line, and then let's suppose the point is here. Okay, and then we can see that this point is to the below and to the left of this indifference curve, and obviously this is not in the upper contour set, right? Good. So this is convex, this is non-convex. Okay. All right. So go back to the interpretation of this, of the convexity. So normally we can interpret this as the diminishing marginal rates of substitution, right? So normally we have different kinds of marginal rates of substitution. We have diminishing or increasing or neither of those, right? So that means with this convex preferences, so from any initial consumption situation X, and for any two commodities or for two goods, it takes increasingly larger amounts of one commodity to compensate for successive unit losses of the other, right? And this would be a very natural assumption for decision makers, especially for human, right? Okay, so let's write this down as in terms of a diminishing marginal rates of substitution, right? So we could see this directly from the picture, right? So because as we move along this indifference curve, when we decrease the amount of x2, then we need to increase a large amount of x1 to still keep this in the indifference curve, right? So that's the interpretation of this point. Good. All right, so we might also have other interesting interpretations regarding this property, but we won't just exhaust all those explanations. You could have a read on the textbook in this chapter. Okay, so good. So next, let's introduce a relevant property to this, which is called strict convexity. Okay, so this would be definition 3.b.5. Okay, so we say that preference relation on X, it is strictly convex if for every X element little x in big X, we have still 2 points, y and z are weakly preferred to X, and those are 2 different points, and those imply the convex combination is strictly better than X. Okay. and for all alpha. And be careful that this alpha now, it doesn't include the two boundaries. Okay, so this is the open set. Good. So again, similarly, we draw some pictures, maybe one picture, to indicate a counterexample for that. Okay, so let's try to have example that is convex, but that is not strictly convex. Okay, and you could perhaps immediately imagine some example, right? So we simply need a straight line or a straight segment as part of the indifference curve, right? Good. So okay, so this would be x1, x2. Okay. So let's have a straight line in the middle of this utility, not utility, in the middle of this indifference curve. And then we draw some curves. Okay. Good. So, and we see that a part of this indifference curve is straight, right? So let's suppose if x is somewhere here, y is here, and z is here, okay? And so you could simply pick any alpha, and this alpha would be still somewhere on this segment, right? Between y and z. So you can see that this is still convex, but it is not strictly convex, right? Because this alpha y plus y minus alpha z, this is not strictly better than x. It's still on this indifference curve, right? Good. So all right. So this would be the upper contour set, and this is the lower contour set, right? Okay, so those are the also very important properties, right? So those are the convexity and strong convexity for the preference relation, okay? And the basic intuition or the main interpretation of those convexity properties are the diminishing marginal rates of substitution. Okay, good. So in the next episode, we'll introduce another very important property and also try to see that what do we need else to further evaluate or to analyze the decision-making problem toward the preference-based approach. Okay.